Hello students, I hope you're all doing well. Welcome to another video by QuickStudy. In this video, we will cover the topic of periodic table. So let us begin. The modern periodic table has over 100 chemical elements which have been isolated and identified. Each elements are arranged in the basis of increasing atomic number. Each element has one more proton than the element preceding it. This is done so that elements end up in same columns with other elements which have similar properties. The table is arranged in vertical columns called groups and horizontal rows called periods. The first 7 groups are numbered 1 to 7, while the final group is numbered 0. The group numbers show how many outer electrons there are in each atom from groups 1 to 7. This means, for example, a group 1 element has 1 valence electron in their outer shell, whereas a group 6 element has 6 electrons in their outer shell of every atom, and so on. Periods show the number of electron shells an atom has and are numbered 1 to 7. This means, for example, elements in group period 2 have two shells, whereas an element in period 7 has 7 electron shells in every atom. The 8th group of the periodic table, called group 0, consists of noble gases. These elements have 8 electrons in their outermost shell. This results in the elements being almost completely unreactive. This is because since their outermost shell is full, they have no tendency to lose, gain, or share electrons in a chemical reaction, thus resulting them in being unreactive. The diagram below shows the noble gases in group 8. Now, let us move on to the metals and nonmetals of the periodic table. The metals are on the left-hand side of the periodic table, and the nonmetals are on the right-hand side, as shown in the diagram below. In reality, however, there is a lot of uncertainty on the line dividing the metals from nonmetals. For example, arsenic has properties of both metals and nonmetals. Now, what are some general properties of metals and nonmetals? Metals usually have 1 to 3 outer shell electrons, whereas nonmetals have 4 to 7 electrons in their outermost shell. Metals have metallic bond due to losing their outer shell electrons. This will be elaborated more on the chapter of metallic bonding. On the other hand, nonmetals have covalent bonding due to the sharing of their outermost electrons. This will be elaborated more again on the chapter of covalent bond. Metals lose electrons in chemical reactions, whereas nonmetals gain electrons. For metals, reactivity decreases down the group. This is due to the increasing atomic size down the group, for which the outer shell electrons become further away from the nucleus. As the atomic size increases and the outer shell becomes further away from the nucleus, the outermost shell electrons experience a weaker force of attraction from the nucleus. Since this attraction is weaker, the valence electrons are more easily lost during the chemical reaction, and thus the reactivity increases down the group for metals. In nonmetals, the opposite happens. Reactivity decreases down the group. This is because down the group, the outer shell becomes further away from the nucleus due to the increasing atomic size. Since in nonmetals, the elements gain electrons in a reaction, the electrons involved in the chemical reactions experience a weaker force of attraction from the nucleus due to the increasing atomic size. Therefore, down the group, the reactivity of nonmetals decreases. Metals are generally good conductors of electricity. Nonmetals, on the other hand, generally do not conduct electricity. Metals generally form basic oxides. A basic oxide is one which reacts with acid to form a salt. For example, copper 2 oxide, which is a base, reacts with sulfuric acid to form the salt copper 2 sulfate. Nonmetals generally form acidic oxides. Acidic oxides react with bases or alkalis to form salts. For example, carbon dioxide, which is an acidic oxide, reacts with sodium hydroxide to form the salt sodium carbonate. Metals tend to be solids with high melting and boiling points and with relatively high densities. Nonmetals, on the other hand, tend to have low boiling and melting points, although there are some exceptions, such as carbon and silicon. Metals are malleable, which means they can be hammered into shapes. Metals are also ductile, which means they can be drawn into wires, and they are usually good conductors of heat. Nonmetals are usually brittle when they are solids, and they are usually poor conductors of heat, with, however, the exception of diamond, which is exceptionally hard and also the best conductor of heat among all metals. Metals form ionic compounds and usually form positive ions in their compounds. Nonmetals form both ionic and covalent compounds, and they tend to form negative ions in the compounds. With this, we have come towards the end of this video. Now let us have a quick recap of what we learned so far. We learned how the elements are arranged in periodic tables in vertical groups and horizontal periods. We understood how the group number denotes the number of outermost shell electrons an element has, while the period number shows how many total shells an element has. We also learned about how metals and nonmetals are arranged in the periodic table and the general properties of metals and nonmetals. Thank you for watching this video. If you like this video, do consider subscribing to our channel as we post regularly on different topics and subjects covering the GCSE syllabus to help you ace your exams. For more information on our one-on-one online tutoring services, do visit our website www.quickstudy.uk. Thank you.